Hi, I'm Himadri. In today's video, I'll be demonstrating the pfSense firewall that I have deployed as part of my SOC Lab environment. Before diving into the configuration, let me briefly explain what pfSense is and how I'm using it in this project. So, pfSense is an open source firewall and router platform based on FreeBSD. It provides enterprise grade network security features such as firewall rules enforcement, NAT, DHCP services, VPN support, traffic logging, and network segmentation. In my SOC Lab architecture, pfSense acts as the perimeter firewall between the simulated internet and my internal network. It allows me to control traffic flow, generate network logs, and create realistic security events that can later be forwarded to a SIM for monitoring and detection engineering practice. Now, I'll walk you through the dashboard, interface configuration, DHCP services, firewall rules, and system logs to show how the environment is structured. So let's begin now. This is the pfSense dashboard, the central firewall of my SOC lab. From here, I can monitor interfaces status, CPU and memory usage, gateway health, and real time traffic statistics. This is the interface status page of pfSense. Here, I can verify that both WAN and LAN interfaces are operational. The WAN interface is connected to VMware NAT and has obtained an IP address via DHCP. This simulates an external internet connection for the lab environment. The LAN interface is configured with the IP, which acts as the default gateway for my internal SOC network. All internal endpoints route their traffic through this interface. From here, I can also monitor packet statistics to confirm traffic is flowing correctly between networks. Here, pfSense is configured to act as the DHCP server for the LAN interface. This allows internal machine to automatically receive IP addresses within the 192.168.174.0 subnet range. The address pool is defined from 192.168.174.10 to 192.168.174.245. I've intentionally reserved lower addresses for infrastructure components like servers or static assignments. This ensures centralized IP management and simplifies scaling the lab as I add more endpoints. This is the WAN interface rule set. As you can see, there are no explicit pass rules configured. That means all unsolicited inbound traffic from the internal network is blocked by default. This follows a deny by default parameter security model. These are LAN interface rules. Here, internal machines are allowed to initiate outbound connection. The default allow LAN to any rule permits internal host to access external networks. The anti-lockout rule ensures I don't accidentally block administrative access to the firewall. This is the system log view. It records kernel level and service level events such as interface initialization, driver loading, and system boot processes. These logs are useful for troubleshooting firewall stability and hardware level issues. This is the firewall log view. Here we can see real-time traffic events including block and allowed connections. These entries show traffic that was blocked by default deny rule, specifically IPv6 traffic on the LAN interface. Every packet entering an interface is evaluated against the rule set applied to that interface, and the result is logged. All these logs will later be forwarded to my SIM platform for centralized monitoring, correlation, and alert analysis. To summarize, pfSense serves as the network visibility and enforcement layer of my SOC lab. It manages traffic between the simulated external network and my internal environment while generating valuable firewall logs for analysis. With this firewall foundation in place, the next step in my lab setup will be integrating a SIM solution and deploying endpoints to begin collecting and analyzing security telemetry. I've also added the link to my Medium blog in the description where I've explained the complete step by step setup process of pfSense in detail. So you can follow along and build your own lab environment. Thanks for watching. I'll continue building this SOC lab step by step in the upcoming videos. See you in the next one.